So what's next? We need to hunt for a new equation. Now, looking at that last equation, it doesn't seem like it's not a it's like the wrong family, like it should be natural log or inverse or something like that. It seems like it's the right equation. And so what we can do is we can tweak the equation. Now, what is true is that increasing the order of the polynomial fit will always increase the quality of the fit. Therefore, a better fit, especially where we need it, doesn't mean it's the true relationship. It just works. It's a model. So how do we know when to stop increasing the order of the polynomial? The short answer and the simple answer is when I'm able to get the answer I'm looking for. So when we look at that, where is the angle the maximum, we can see here now every single location, y hat, those values are agreeing with and are crossing the vertical part of those error bars. So that means it works, and it seems to work well there. So that's the first thing. And the second way we know is when there's no pattern in the residuals, especially where I need it most. So when we make a residual plot for this second case, what we look at here is it doesn't seem to follow any smooth function. So is there a pattern in the residuals? What we look for is it's not a smooth function. And the second is the residuals are unpredictable. So here's the way to test yourself. And the way to test if it's predictable or not predictable is to choose 3 points. All right, so let me choose these 3 points. 1, 2, 3. Choose 3 points. Is the middle one, or could you have predicted the middle one, looking at just the outside? Based on the ones on either side. So if we take a look at these 3 points, if I look at these two, I would have predicted a point in the middle might have been there. So I was wrong. Strike 1. Let me pick another 3. 1, 2, 3. All right, I might have predicted right here. So I would say that's not a strike. So we're -1, +1. And let's pick another 3. 1, 2, 3. I might have predicted there. So we agree with whether it's positive or negative. So could we have predicted? We want to know, is the positive and negative correct? And is the magnitude correct? So is the direction, is it if it's positive or negative, and how large it is? So in the first case, we weren't even right whether it was positive or negative. We thought it would be positive, but it was actually negative. The second case, we thought it would be negative, and it was. And it was pretty close to being as far off as we thought. When we choose the next 3, 1, 2, 3. We predicted here, and we were right about it being negative, but we were way off on the magnitude. And now we could choose, and we don't have to just choose the next successive 3. We could choose some of those that are included. So, for example, we could choose this one, and this one. Oh, those are the ones we already chose. We chose those 3, we'd be spot on. And if we chose these 3, we'd be spot on. If we chose those 3, we'd be spot on. If we come over here and we had chosen, and let me use a highlighter here, this one, and this one, well, I would suggest that we would have picked the point to be here. So we would be wrong about the plus and minus. We'd be wrong about the plus and minus and the magnitude. So that's a miss. And now we choose these 3 points. We would have probably chosen about here. We would have been correct about the negative, but not the magnitude. So that's kind of uncertain. We'll put that as an equal. We choose these 3 points. We'd have chosen here. We're not right about the sign or the magnitude, so that's a minus. The next 3, we would have been spot on. These 3, we would have been right on the positive, but way off on the magnitude and so forth. The bottom line is that when we look at this overall thing, we don't look at this and say, oh, it's a line. Oh, it's a parabola. Oh, it's a trig function. We don't look at this and say this is a nice mathematical set of data like this other residual plot was pretty clearly this trend that we could draw a smooth curve through. Whereas this residual, we can't do that. It's unpredictable. So that's what tells us. So therefore, we can't falsify. We can't falsify this. The residuals are random, unpredictable. So that means that the variation and variation or deviation from the between y and y hat, the actual values and the predicted values, is random, not because it's the wrong function.